When you walk outside and look up, if it's a nice day, you'll see a bright blue sky. Why is the sky this color during the day, while at night we see how space is black? On Luna, for instance, the sky is black day or night. There is something getting in the way of that black space that is showing us blue. That thing is the atmosphere. The atmosphere is made up of molecules, mostly nitrogen, a fair portion of oxygen, a little bit of argon, and traces of practically everything else. Light interacts with these molecules differently based on their properties. Nitrogen and oxygen tend to reflect shorter wavelengths of light, while letting longer ones pass. This means that when a complete spectrum of visible light passes through the atmosphere, violet and blue are filtered out first, then green and yellow, and finally orange and red. That means that when Sol's light passes through the atmosphere, the blue and violet are scattered throughout the sky, and we see them coming from every direction, while the other colors are just coming from the direction of Sol. This might make you ask why the sky isn't violet. The reason is that although Sol's light is white, a mix of all the colors in the visible light spectrum, it produces more green than the other colors, and less violet and red than the other colors. On top of that, the human eye can detect blue easier than violet. That is why the sky is blue and not violet. Now you may be thinking, Sol isn't white, it's yellow. However, this is just another symptom of blue skies. With blue and violet light being diverted from Sol, its light is tinted slightly yellow. Also, the fact that it is surrounded by a blue sky makes it look even more yellow in contrast. Another thing is that at sunrise and sunset, Sol can look orange. The reason is that at sunrise and sunset, Sol's light needs to pass through more atmosphere than at midday. It is simple geometry, really, and since the light is passing through more atmosphere, longer wavelengths of light get filtered out. Green and yellow are filtered out of Sol's light and scattered off of the air nearby. That is why the sky around the rising or setting Sol looks yellow or other colors, and Sol itself looks orange. Interestingly, this means that if Earth had a thicker atmosphere, the sky would always look like sunrise and sunset. And if Earth had a thinner atmosphere, the sky would only look normal at sunrise and sunset. Also, during lunar eclipses, Luna looks red. This is because while it's in shadow, the only light shining on Luna has been filtered through even more atmosphere than a sunrise or sunset. Going through that much atmosphere results in violet, blue, green, yellow, and even orange to be filtered out of the light. This leaves only red light to shine on Luna and be reflected back towards Earth. All in all, the atmosphere filters out short wavelengths of light in a process known as Rayleigh scattering. How much atmosphere the light passes through determines how much light is filtered out.